Good morning, welcome, good evening, good afternoon, wherever you are in the world. This is a joint webinar by the IDTA Association and the OPC Foundation. We have an amazing interest on the topic how to combine both technologies, the asset administration shell and OPC UA. And I try to do this introduction as short as possible. Please use the question window as an attendee to insert all your questions you have. The team will stay online and provide all answers. Recording and slides will be shared, but with this, I hand over to Frank Volkmann from Siemens. He is the lead of a proof of concept how to unify both technologies. And I hope, Frank, are you online? Can you please, one after the other, introduce in the time also your co-speakers and report about your amazing results of this, bringing these technologies together. Frank, are you there?
Yeah, thank you, Stefan, and thank you especially for having us here. I want to represent today the joint working group between the IDTA and the OPC Foundation, as Stefan already mentioned. And especially, we want to present you today the POC that we did, and the POC consists of a common meta information model and a common web-based communication with AAS and OPC UA information in one POC, in one software. What we want to do today is we want to show you the part of the standardized model and the focus of the models of the IAS and OPC UA on one side, and then I will shortly show you or introduce you the joint working groups that we built between the two organizations. That is the more organizational part. And then I give you a rough overview about the common meta information model and the reasons why we did that. And second, the common communication model, and as an outlook, the enhanced communication model. And after that, we will give you a live presentation of the POC so you can see how it works and how it feels, how it looks like. And last but not least, we will have a Q&A discussion at the end. I'm not presenting alone today. We have normally three presenters. This is Niels Bauer, Constanze Bieler, and Zoe Dickekar. Unfortunately, Constanze got ill, so we take over her part. And we will introduce the co-speakers at the time when we hand over from one to the other one. Next. So first of all, as I said, I will give you, let me say, a landscape picture how the things belong together. And the anchor of the landscape is the life cycle of a product. So the life cycle starts with an ideation of a planning and so on. And at the end, this product is dead. But also after a product is dead, there are some activities related to that product or asset. And with the colors you see, let me say, focus, the coverage in red from the AAS part and in blue from the OPC UA part. And you see that we have a transition here between the colors. And this means that these fences are not fixed. So it's a smooth transition between where the focuses of the two technologies are. And so both together will bring you the benefit at all. The technology itself, or the technologies, have for their information digital representations in information models. So you have the AAS information with AAS submodels, submodel templates, and so on. And on the other side, you have the OPC UA information and OPC UA information models based on the OPC UA meta model. And they are written in companion specifications and normal specifications and defining that information models. To access this information, both have their own APIs. So AAS has an AAS API and OPC UA has a couple of OPC UA APIs in different technologies. And so an application has to access that information today with different channels. So you can access AAS or OPC UA normally in different applications, not in one combined application, and you have different accesses to the different information models. So since 2023, we founded the joint working group between the IDTA and the OPC Foundation. And the reason is that we saw that we have several use cases, several things where we can benefit when we are combining things and harmonizing things in between that two. So we founded that joint working group. The joint working group is chaired by Professor Christian Diedrich still to today, from the beginning. And this joint working group, as any joint working group, by the way, is open for all members of the IDTA and the OPC Foundation, all members of the organizations that are part of the joint working group. The IDTA, I don't think that I have to mention that here. The IDTA is the Industrial Digital Twin Association, and the OPC Foundation is the OPC Foundation. Sure. What we are doing in the joint working group is we want to combine or to have in a result one beta model, one model where we are modeling the information at the end. So we have a sub-working group with a generic meta model translation. You will hear much more about that over the time today. The second one, this is a very important one. This is the maintain similarities group. They are responsible for finding overlaps and so on, and then when they find some, solving them. And what's mentionable at this point, and for me still fascinating, they are using HI mechanisms to find such similarities in between different specifications. But we will not hear much about the maintain similarities today. Then we have the common communication, and the common communication has the goal to have one communication access point for both, for AAS and OPC UA, in one communication channel at the end. And last but not least, the fourth sub-working group of the joint working group is the group that is managing relationships in between the two models. And we have two approaches here. And I always say there is a black box approach, that is a server data sheet. With that one, you can give in an AAS information model, you can give the hint that there is another OPC UA server that can you give further information. So this is a black box because it's just a server reference. And then with AID and AIMC, we have, I call it white box view. There you can relate directly from an information element inside the information model to another information model in the other information element in the other information model. And the third big task of the joint working group for sure is to be the head of the sub-working groups and discussing and solving any technical problem related to both standards at the same time. So coming back to the landscape picture, I show it again because I now want to relate or to position the four sub-working groups that we have, and I already told you a minute ago. So we have that common communication sub-working group that is dealing with the communication part for sure between the application and a server that can communicate both AAS and OPC UA. Then we have the translation. This is a generic submodel or generic information model group. This is a translation group. And for sure, they are dealing with the information models, with the digital representation. Then we have the AAD, and server data sheet, and they are related to the digital representation in between the models. And the similarities working group is working on the interface part, let me say so, the overlapping part of the two specification worlds, and yeah, solving such problems when they occur at this point. That was a little bit too fast. The POC itself only covers 2 of the 4 working groups. This is one is the common communication, and you will hear about that in some minutes from Niels. And the second part is the translation. These are the 2 sub-working groups where this POC is working for. And for sure, both communication and translation has OPC UA parts or flavors, and also AAS flavors. We will sort that out later. So now we are coming to the one common meta model, and what's the reason for that one? One common meta model means that we have one meta model for both sides, for the AAS side and for the OPC UA side. And I want to show you a picture that's very old. It's from 2019, so 6 years old. And it's not from us, it's from the IEC. And in this paper, you see that at this time point, it was demanded that we need a shared model to interop between different models. That's a quite easy result when you think about that you need that. But it wasn't there. And that is one of the points that we did today. And so in our POC and also in the joint working group, we decided to use that implementation here. So on one side, we have the AAS with their AAS submodels, and we translate them to an OPC UA meta model. And the reasons for that I will explain later. And in this OPC UA meta model, we also have the OPC UA companion specs and the different OPC UA informations. So with that one OPC UA meta model based information model, we combine any information from the AAS and from OPC UA. And when you have that common information model, it's quite easy to access them in the same way. So what we get is we have one database, one digital representation for any information, not an AAS information and separately an UA information. It's one database, one information. We have the same meta modeling language, and with the generic translation, we can automatically translate any AAS submodel or submodel template to that OPC UA meta model. And so we get them in one data source. And as I said, I want to repeat it because it's very important. We have one rule set and we get one translation, and this can be done automatically, and it is already done today in other POC. And this is not only true for the, let me say, well-defined companion specs and submodel templates that are there, but you can use the same technology to map also any vendor-specific specification. When you have it in an AAS form, you can bring it to OPC UA. And one point, at this time point, we decided that we map AAS to OPC UA because there are mechanisms and possibilities in OPC UA that you cannot map back to to AAS. So we decided to do the mapping from AAS to OPC UA. But when we did that and we started the discussion about that one, we get immediately the feedback that the people want also the way back, so that you can map OPC UA information to AAS. And that is also a point that we specify in the sub-working group, in the specification, but there is a limit. You have to limit yourself when you are modeling information in OPC UA with the standard OPC UA modeling tools like UA Modeler or the OMO or whatever, that you have to limit yourself to the, let me say, language set of AAS. Then you can map it directly back. So you can use in future the OPC UA modeling tools to model your AAS submodel templates. And at the end, what we achieved is that we realized the proposal and the idea of the IEC white paper. That's my 500-meter overview about the common information model. We will have a deeper look inside and how it works in Constance's talk. And as I already mentioned, unfortunately, she is ill today. So Niels and myself, we will take over this part, but this information will come later to you. My second part that I also want to give you the 500-meter overview is the common communication. So I have just a simple picture for that one. And this picture shows you that you have one common database. That is what I explained already, that we combine any information in one database and realized in an OPC UA meta model. And this can be part, for example, inside an edge or whatever. And normally you have such a database inside your system. If not, you can have it there. And so you can have other clients that can access it, but that's not the focus for today. Important is that you have sources to fill up that database. In our case, that are field devices and concrete for the POC. This is a drive from Siemens that we are using here. And all that information is collected in that one database. And this database is communicating with our common communication server. And now that is what the common communication is doing. You have a client here, and this client is at the same time an AAS client and OPC UA client, because we have only one communication stack. So this client can access AAS information and OPC UA information at the same time via the same connection. Connection in quotes, when you are using REST, then you not really have a communication channel, but you have, let me say, a logical communication, but you have different requests. That only for the experts. And when you are using WebSockets, that is the enhanced communication, then you really have one communication channel based on TCP/IP. And then you have that big orange box here with the common communication server, and that is exactly what Niels will tell you in a moment. But before I hand over to Niels, I want to introduce him. Niels Bauer is, since 5 years, expert in OPC UA technologies at Siemens. So he is a direct colleague from myself. He is doing the OPC UA FX prototyping for Siemens. And that was my first part that I did together with Niels. That was the prototyping for the part 21. Part 21, as OPC UA part 21. This is device provisioning. That's a very important work for the future because that is deep security related. And last but not least, the third big part that he did regarding OPC UA is support also with this programming for the Profi Energy specification work. In the POC that we are presenting today, he is the technical lead of the POC. He is responsible that all the parts, as I said, we are 3 developers in the POC. He brings all the parts together, and he is developing that orange part more or less from that outside view with the Docker container and so on. and inside that orange box, all of the OPC UA parts. And he gives you also the white box of that orange block, and then he will explain what are the tasks from the other people that are helping here, so Constanze and Zoe. And for sure, for this work, he is also a member of the Common Communication Working Group, because we want to bring in our what we learn about in the POC. We want to bring into the sub-working groups that this knowledge will come to the specification itself. And last but not least, last word about that one. He will be he will take over my role at Siemens in some time, and so in future he will be the technical representative of the Siemens AG at the OPC Foundation. So thank you. That's my part for the moment, and I hand over to Niels. Your stage.
So thank you, Frank, for the introduction and providing us an overview about our topic. Now, before we dive deeper into the technical solution, I would like to share few more details about our team and the POC. So the POC was initiated by Siemens with the support of the IDTA and the OPC Foundation. And we want to verify today's existing features together with the new enhancements, which we discuss in the near future. To ensure that we have a real industrial environment use case, you will see on later slides and also in our live demonstration that we are utilizing the product carbon footprint submodel template for the AAS part. And for OPC UA, we have a companion specification of the energy management. And this then will be shown inside our live demonstration. I also want already to give a little bit of look into the future, because I'm pleased to mention that this project is serving as a foundation for a master thesis at the ACAD University of Stuttgart, which will showcase the work and the results of the mapping sub-working group, who have had a significant impact in our project. Now let's start to dive a little bit deeper inside our common communication server. And yeah, let me give you a little bit more detailed view on this big orange block. So in our proof of concept, like Frank already mentioned, we have one web application which is used for an AAS and OPC UA client to access our informations. This client can connect via REST or via WebSocket to our open web container using interfaces which are already defined by an OpenAPI schema. This OpenAPI schema is already used today from the IDTA and from the OPC Foundation in different projects. Now, after a connection is established and a client can send the AAS or OPC UA requests via one interface. Inside our container, then we have to distinguish between two paths, and this is because OPC UA and AAS are a little bit different then. In case of OPC UA, the request can be translated to a corresponding OPC UA binary call. And this binary call can be then given directly to an OPC UA client, which uses the today's standardized client-server methods to execute a request to our meta information model and gets the result back, and can easily transform these results to the required OPC UA format back, so that our web client gets the correct response to his request. Now, in case of AAS, it's a little bit different, because AAS when an AAS request comes into our container, we cannot just translate that AAS call to a OPC UA binary call. This is because an AAS request can be a combination of multiple OPC UA calls. So we need to have a specific or a good translation between the AAS and our OPC UA client functionality. Here also, when it's translated, we already, like on the OPC UA path, we have the standardized client-server methods to get these requests. And when we have the results, we have to do a second translation because the AAS web request needs also a specific format for its response. So we are doing a second translation and can then respond to that call. So with this in mind, our proof of concept had three major topics we had to work on. First was the common meta model, so that we have a database which AAS and OPC UA informations can be stored. The second big topic was the handling of AAS requests, and here also the translations from AAS requests and the results to the right format. And then second and thirdly, the task of getting the OPC UA calls and making the correct request responses. In each of these topics, we had a designated team member with their own expertise, and each of these topics will be presented from us, as Frank already mentioned. Sadly, Constanze can't be here today, so we will try to give you the best expertise we can do. I also want to mention that we did not start from scratch, but we used an already existing implementation for an OPC UA REST function project, which was done from Randy Armstrong, and he is a member of the OPC Foundation. Now, what tasks did we, or which work packages did we then have in the POC? So first of all, we had to ensure that we can join the REST communication from today's AAS REST and OPC UA REST. Then one of the biggest points was the translation of the AAS functions, so that we can have these sequence of OPC UA service calls and also the correct responses that our AAS web client can handle these. Also, the mapping of the information model was a big working package, since we had to do, or we did the AAS submodel, or we mapped the AAS submodel into our OPC UA information model, utilizing the rules which were made by the generic sub-working group of the generic mapping. Here we can say that there is a tool chain, or it's been worked on a tool chain for an automatic translation. It's still ongoing. Now, we only talked about the REST calls. I also mentioned that we are having the possibility to use WebSockets. And for this, we have our enhanced communication. There we had to do an WebSocket communication, which is extending the REST communication stacks. So we wanted to ensure that today's existing REST communications does not need to be changed, but that we have a possibility to upgrade to WebSockets. And also for the AAS, we had to add a few things like adding a call header, or also then for the response header. But these additions will be presented by Zoe later on. Now, how does the transition from today's communication to the enhanced communication will work? So in today's REST communication, it's a client operates with sending its requests, including a full HTTP header and its requested envelope to a designated server. And after the server processes the request and has its result, it then sends the response with a matching REST envelope back to the client. This sequence continues as long as a client then decides that he wants to upgrade to the enhanced communication. For this, the client will send a so-called upgrade request to the server, and then the server can decide if he will accept this upgrade call or if he declines it. In the case of declining, the server will just respond with an error code, and the communication will then continue with REST. So there is no interruption. If the server accepts the upgrade call, it will respond with a 101 switching protocol status. And at this point, the client does not have to send the entire HTTP header anymore, but only the requested body with his request. This enhanced communication can last as long as one of the communication partners, either client or server, closes the WebSocket communication. And after closing, the communication can also continue then with REST. That may sound pretty complicated, but I have a little sample code which shows that it's not that complicated, because in reality we only need a few lines of code. So we have to open a WebSocket, create an event listener, which will be triggered when we get responses, and then we also just can send, or when the WebSocket is created, we can send our body or our request. Now, I've talked a little bit about, or what I talked about now is that we are enhance our communication with removing overheads. But there are also more functionalities which can be, or which brought by the enhancement. First, I want to reiterate that base functionality still allows for the use of today's AAS and OPC UA REST functionalities, meaning there's no changes required. And it's also possible to use the same HTTP REST for both AAS and OPC UA. Now, the enhancement offers the improvement of performance, which means that we do not have that overhead of every HTTP header. But furthermore, it also enables the addition of currently missing features such as session handling, dynamic data, and user authentication, which are adopted by today's OPC UA functionalities. Now, before we come to our next part, I wanted to share also a little bit about my personal learnings from the POC. Coming from the development of C and C++, I had no knowledge of web development. So working with React and TypeScript was completely new and challenging. I also had only a few minor touch points with REST, but in both topics, Randy Armstrong's implementation was very helpful, and also working together with Zoe on this topic brought a very good learning curve. Regarding AAS, I only heard a little bit from it from colleagues or read some articles about it. But now, after working with it, I can see similarities between AAS and OPC UA. And for me, it's not anymore, or it's not a competition between AAS and OPC UA. It's rather a powerful foundation which can be achieved when they are both combined. So because everyone has their, like Frank mentioned, in the life cycle, product life cycle, their parts. Finally, I really enjoyed working with everyone on this project, and want also to take this opportunity to thank everyone who was involved in this POC. And now we will come to our next part, which would have been presented by Constanze Bieler. Constanze did her Bachelor of Science at the Technische Hochschule Nürnberg with her topic of communication between OPC UA and AAS, also already in the cooperation with Siemens. And in the POC, she was the technical expert for the information model mapping of AAS to OPC UA, in which she also took part in the sub-working group of the submodel mapping. And at the moment, she's working on her master thesis with the topic AAS OPC UA in context of Factory X at the ACAD University Stuttgart, and will be finished with it in the mid-2026. So, like already mentioned, Constanze's main topic was the mapping of the AAS submodel templates to our common meta information model. For this, she is part of the subworking group of the generic submodel mapping, which task it is to create a rule set to map any AAS submodel template to an OPC UA meta model. Since these rules can be programmed, it's also possible to make the mapping automatically, which can already be seen by a prototype in the OPC UA cloud library. The prototype and the draft of the specifications are at the moment not fully aligned, but this work is in progress here. And one of the results Constanze's work is that every submodel can be modeled or mapped in OPC UA, but the reverse way is not fully possible, since OPC UA has more modeling possibilities. For example, there are more types and references in OPC UA than we can be built in AAS. For the POC, Constanze mapped also the product carbon footprint model manually using the rule sets of the generic mapping subworking group. The results of her work were fed back directly to the working group and was very helpful. To complete also our use case shown by the POC, it was necessary to use the energy management companion specification and a custom information model from a drive, which she did also implement. Now the product carbon footprint submodel template, which will be shown later on, consists of 9 elements. But for us, the POC, we only, or for us, the really important thing was this PCF O2 equivalent. And yeah, we will have a closer look on it later on.
So I jump in now, and I want to present you, let me say, the target, how it looks like in the OPC UA information model, and how are the AAS information is modeled inside the OPC UA information model, and where are the anchor points of that information. And I will do that in 2 different slides. One slide for the type model. So that is what you see in the moment. And you see here in blue on the left side, that is the type model that we have in OPC UA. And then you see that in the yellow part, that we just add the AAS types. I cannot really read that small letters here. So we have the AAS environment type here, for example, and the submodel type and so on. This is in the yellow part, and that are, let me say, the base types of the AAS, and they are inherited from the base types of OPC UA, like the object type or the variable type. And there is a third level, let me say so, from type inheritation, and that is then for concrete types, like at the end, the product carbon footprint, for example. You see that one here. We have the transport product carbon footprint and the product carbon footprint type here, and they are inherited from the submodel element object type and so on. So that is how the type mapping is done in a generic matter from an AAS submodel template to the OPC UA information model for the types. And more or less, we did the same thing for the instance part. So again in blue, so we have the same colors here. Makes sense, I guess. So we have in blue the object information, or the objects information, object in the information model. That in that one, all instance parts are resided in OPC UA, and then we created the yellow part here, and that is, let me say, the framework or the anchor parts of the AAS information. Someone killed our screen. Do you see something? Ah, it's back again. Okay, sorry for that one. I lost the screen for a moment. Yeah, what I said is that we have that OPC UA anchor in the instance model, that is the object, and below of that one, we put in our AAS parts, the AAS environment, the drive asset administration shell, for example, and then we have the drive product carbon footprint here. So the yellow part is the instance part of the submodel inside the OPC UA information model. And as we already mentioned, we have one information model for AAS and OPC UA. So we for sure also have the OPC UA information, the instances, for example, for the drive and so on, in the same information model. And this is the green part here below. And what you see is that we introduce or use different references between that, let me say, OPC UA instances, like the my drive or power value here, and we are creating references. That references and so brings them in a relationship between that OPC UA instances and the AAS instances. For example, we have that power value here from the drive, that is the current consumption. And we have the AAS product carbon footprint CO2 equivalent here. This is not the same value. You have to do a calculation in between, but the CO2 equivalent is directly influenced by the power of the drive, the current consumption, and that we reflect with a new reference type that is influences or influenced by. And that is the way how we bring the things together in the common information meta model. So we have all information in the meta model, and we get in addition the benefit or the synergy effect that we can now have additional references in between the parts to show in the information model things that are belonging together. It's more an example, but it's a very general one. So from the different elements that we have in the AAS meta model, most of them we can directly, let me say, map or translate to two base mechanisms of OPC UA, and that is elements that have a value. They can be mapped to OPC UA variables or subtypes of variables. And on the other side, elements that have a structural meaning that can directly be mapped to object types or subtypes of object types. So you can create your AAS submodel template structure directly one by one or one-to-one using UA objects to model the structures and UA variables to model the values or the variables that have values. That was my short jump in to explain you how it looks like in OPC UA, and I give back to Niels, and he gives the last two slides from Constance's part.
Yeah, thank you. So, like we said in the beginning, the POC consists of an OPC UA server which has the carbon footprint submodel and the energy management companion specification inside. And this is done by us with using the Siemens IIH OPC UA server. The values for the energy management are directly read from a motor simulation, and the values for the CO2 equivalent is calculated in a third intermediary OPC UA server, which takes all the needed values from the drive and transfers them into our information model of the IIH. The reason for that intermediate OPC UA server is that we didn't want to program directly in our IIH server, but this is only for the POC. In future, we will utilize the full IIH mechanisms for this. Now I want to give over to our last team member. This is Zoe Tikekar. She has already more than 4 years experience in AAS technologies and did different development and implementations of AAS and OPC UA for different research and industrial projects. She is leading an AAS test engine developers group at the IDTA and is driving forward the open source development to make AAS as a de facto standard. Inside our POC, she was my counterpart, I would say, since I did the OPC UA part, she was responsible for the AAS REST interface, the WebSocket enhancement for AAS, and also the translations from the AAS functions to the different OPC UA codes. With me, she also was a member of the sub-working group from Common Communication. And I'm happy to say that she is, she's already doing her PhD at the RWTH Aachen and develop and evaluating of industrial information model connectivity for AAS, OPC UA, and MQTT. With that, I give over the control. One moment, please. Now you should have access.
Yes, I have that. Thank you so much, Niels, for such a warm introduction. Yes. So, hello, everyone. I'm sure you must have seen this architecture diagram for a couple of times now, but for next few minutes, we will be focusing on the role of asset administration shell in this whole POC. So that is nothing but what we see here in this purple box. So let's get started. So as we have already heard, this POC, even with respect to asset administration shell, it supports both the protocols, that is REST and WebSocket. So when it comes to REST, we of course support the traditional request response model. But whenever it comes to the dynamic or the live data integration, we rely on the polling mechanism, as the REST does not support the eventing mechanism. However, when it comes to the WebSocket protocol, as we know, it is the bi-directional communication mechanism. That's why we do not need to be dependent on the constant polling at regular intervals. Rather, we leverage this bi-directional mechanism. Now, before we go into the details of how the REST and WebSocket works, I would quickly like to mention here which request are we handling specifically in this POC from the standard asset administration shell APIs. So first of all, we support retrieving all the asset administration shell, retrieving the shells by unique identifiers. Of course, we also retrieve the submodels by the unique identifier within these shells. And we also can fetch the submodel elements using the standard API operations defined in the specifications. So all these four requests we are handling in this POC. Now let's dive deep into how the REST and WebSocket works. So let's start with the REST first. So just like any other application of the HTTP REST, here in this POC as well, the client, as we have seen, sorry. So the client basically sends a request to retrieve the asset administration shell or the submodel data. And as the HTTP REST has a unique endpoint for every resource, the server itself takes care of routing these requests through the controller, fetching the requested resource, and returning back the JSON serialization of the requested element or requested resource. So pretty straightforward here. In addition to this, in the for AAS in this POC, we have also included the data access view. Now, what exactly is this data access view? So to those who have already worked with OPC UA, you might be familiar with the tool called UA Expert. So if we recall this UA Expert, in the middle panel, we have this data access view. And here you can basically add the OPC UA nodes and monitor the live updates of the data being changed. So similar kind of feature we have also introduced with respect to asset administration shell in this POC. Currently, this view is applicable only with respect to the submodel elements. Now, in this data access view, in case of REST specifically, to monitor the live updates, as I mentioned before, we are using the polling mechanism with HTTP REST, and the configured regular interval is basically 3 seconds. Now, if the element is OPC UA backed element, now what does this exactly mean? So as Niels already mentioned, if the element or the value of the submodel element has to be retrieved from this common information model or common database, which is in OPC UA, then we mark this element as OPC UA, and then it is OPC UA backed. And in such cases, we basically use the OPC UA read call or OPC UA read request to fetch the value from the underlying OPC UA server, even in case of asset administration shell. So this is how the REST works. Now let's have a look into how the WebSocket works. So as we have seen in the picture, or how Niels already explained, we are using, in case of WebSocket, a common channel for both the OPC UA request and the AAS request. So we needed a mechanism or a factor which can distinguish the asset administration shell request from OPC UA. And for this reason, we needed to add a few attributes to the request and responses for the asset administration shell. So as we can see here on the top, in case of request, we have the additional attributes such as the service ID, which can distinguish the AAS request and responses from OPC UA. Then we have the AAS request handle, which can track the particular request. Then we have method, and in the end, we have path. So this path basically identifies for which resource the request has arrived. And similarly, in case of response, in addition to the service ID, the request handler, the path, and so on, we have the additional attribute of result. And this result consists of nothing but the JSON serialization of the requested resource. So this is how we handle the request and response in the WebSockets. Now, similar to the REST, we also have the data access view when it comes to the WebSocket. But this time, we do not pull the data, but we rely on the pushed updates from the WebSocket. And in case of OPC UA backed elements, in this case, we do not need to have the OPC UA read mechanism. Now that we have a consistent channel with us, we basically use the OPC UA subscriptions to get the live data from the OPC UA nodes, the corresponding OPC UA nodes. So this is how the REST and WebSocket works. Now, one more factor in this POC when it comes to asset administration shell is translation of AAS functions to OPC UA, as Niels already mentioned in the architecture diagram in detail. Now, as we can see here in the middle picture, so this middle picture is basically the information model or the asset administration shell. And as we can see, a shell consists of different submodels, and every submodel in turn consists of different submodel elements. Now, the values of these submodel elements may be stored in the shell itself, or may be coming from the common database or common information model. So in this case, the OPC UA. Now, how to identify between such two types of elements? So for this, we make use of this extension attribute or extension field from the meta model. And as we can see, so if the name is OPC UA and the value is true, that means this particular element is the OPC UA backed element, and we need to read the corresponding value from the OPC UA information model or the underlying OPC UA server. For example, this PCF CO2 equivalent, so the carbon footprint equivalent. I'm so sorry, I have a little bit of cough, so I'm really sorry for that. Thank you for bearing with me. So as I was saying, this PCF CO2 equivalent, it has the extension of OPC UA, and it is enabled as true. So that means the value of this CO2 equivalent has to be retrieved from the OPC UA information model. So now that we have identified the OPC UA backed element, the next step is naturally to identify the corresponding node into the OPC UA information model. And for this, we need to have the sequence of OPC UA calls to reach to this particular node. And for this translation, for this getting the sequence of calls, we basically make use of the mapping logic that Niels just explained to us. So in simple words, we compare on one hand side the ID shorts of the hierarchical structures of the asset administration shell or all the elements with the type definitions of the corresponding OPC UA nodes on the left-hand side, or here on the OPC UA side. And finally, once we get the corresponding OPC UA node after the sequential OPC UA request or calls, then we, in case of REST, we either make the OPC UA read request, or in case of WebSocket, we just subscribe to this OPC UA node. So this is how, in general, the translation of AAS functions to OPC UA work. So so this was one factor when it comes to this POC and asset administration shell. Now, initially, I also mentioned the data access view, which is a new addition in this POC. So with respect to asset administration shell, and as I mentioned that this is similar to UA Expert or the data access view in UA Expert, and currently we can add any submodel element to this data access view, or we can also remove it. In case of REST, it triggers the polling, and in case of WebSocket, it enables the OPC UA subscription. I would also like to mention here that once the submodel element has been added to this data access view, it is still possible to switch between the protocols such as the REST and the WebSocket. So if we switch to WebSocket, the subscription gets enabled, and if we switch back to REST, then the polling mechanism is enabled. So this is how the data access view is working, and we will see this in detail when we come to the demonstration part. So this was all about different features and functionalities that we have in the POC. Now, I would also like to quickly mention the technical stack that we are using in this POC. So for the meta model structure of asset administration shell, we are using the AAS Core SDK. For backend, we are using the C# SDK, and for front end, we are using the TypeScript SDK. Now, for the API operations of the asset administration shell, be it REST APIs or the WebSocket paths, we are using the IDTA published OpenAPI definitions with the version 3.0.4. And finally, for the OPC UA related functionality, we are using the UA.NET Standard SDK in this POC. Now, just like Niels and Constance, I also had a lot of takeaways with me while working on this POC. So this was the first time that I was working with the WebSocket. So naturally, the comparison between the REST and WebSocket was going on in my head. So as we all know, that the REST is basically, when it comes to one-to-many connection, as it involves the headers and the overhead of dealing with these headers, it integrates a bit of complexity in the application. But in case of WebSocket, as the headers are set only, they are shared or they are sent only once while establishing the connection, the WebSocket helps in performance when it comes to the live data or more frequently changing data. Now, I'm a developer myself, so I found REST very simple to implement. And in case of WebSocket, we need to be, in my experience, we need to be a bit careful of handling a couple of things, such as this WebSocket session management or the socket lifecycle management. Then as the WebSocket is stateful, we also need to think about or consider the reconnection logic that we have. And specifically to this POC, as the OPC UA subscriptions are involved, then we also need to track or keep the track of OPC UA subscription, again, with respect to the WebSocket lifecycle. In addition to that, the REST mechanism is the standard HTTP and pretty straightforward. They have the unique endpoints per resource. But specifically to this POC, we needed to have a specific protocol handling to distinguish between OPC UA and asset administration shell request, as we have seen with these additional attributes. In my experience through this POC, the REST is ideal when it comes to the static or slow changing data, but WebSocket is ideal for the live data integration or very frequently changing data, such as the sensor data or operational data. In conclusion, when the applications can support both the REST and the WebSocket, in my opinion, the application then provides a great strength of flexibility here. So these were my learnings from the REST and WebSocket. In addition to that, I also, so in this POC, we are supporting one asset administration shell. But in future, when there will be multiple asset administration shell in one information model, then for the translation of AAS functions to OPC UA, we will need to have the identifier nodes as well, so as the translation can be worked in optimal way. In addition to that, this was my first time working with the web development and the React, of course. So this was quite an adventure for me, but I definitely have a lot of takeaways as well. And last but not the least, of course, I really enjoyed working with the team, and I would really like to thank all of my team members for their consistent support and guidance throughout this development of this POC. And before I sign off, so in the future, as a part of Outlook, I would be really interested to see or evaluate how the AAS write operations work in this WebSocket, and also the security, how the security plays a role in this. Yeah, so this was all from my side.
So, okay, thank you very much. Yeah, then I will, I think, take over with the live demonstration. For this, just please give me one moment.
We have to start it.
So, okay, then. Okay, so now what you can see here is our web client, which is the base of our foundation for the OPC UA and the AAS visualization. It just needs a moment to load, like the typical live demonstration part. To already start with maybe how it's built up. So we have 3 different sections in our web client. The first one is our OPC UA part, and so you also mentioned it quite often. It maybe some people may recognize it a little bit because we built the OPC UA part like the UA expert. So on the left side, we have our OPC UA server information model where we can browse through our different submodel templates or the companion information model. In the middle, we have our data access view where then I can add different parameters. For example, when I start with that product carbon footprint equivalent, I can add it to my data access view, and here already a read is executed or requested. So this is at the moment a snapshot of the value at the moment. And on the right side, we have our attribute window where I can get different informations about that node. Now in the middle, we will have, or you can see the part for the AAS. Zoe will take over in a moment and will go through the different sections here. And below we have a little bit of a network message where we can then see, okay, what is really requested over the network. Now for the OPC UA parts, as you can, as I said, this is at the moment only one read command, and I can execute a subscription when I go into the banner menu and say that I enable a subscription. And here now you can see that this value is updated in a frequent time. This is now done, everything via REST communication. To show you that this is also possible for WebSocket, I'm closing for a moment the subscription, and with the WebSocket button on the top, I can create a session, and now I'm also can just add my value again. Here, like on REST, it's also first a read, and when I enable my subscription, I get a frequent update of these values. So then, Zoe, hopefully you still have access.
Let me try. Yeah, it seems like it. Okay, so let's start with the asset administration shell. As Niels already mentioned, the middle panel belongs to the functionality related to asset administration shell. And here we see three different panels. So in the left most panel, if I click on it, we can navigate through different the tree-like structure of the asset administration shell. We can navigate through different submodels, different submodel elements. If we click on any of it, in the middle panel, we can also see the detailed information here. And as I have already mentioned, the PCF CO2 equivalent is the OPC UA backed, which we can see here in the extensions. As we can see, the name is OPC UA and the value is true. That means the value has to be basically read from the underlying OPC UA server. Now, in the rightmost panel, this is nothing but the data access view, just like the UA expert. And if I add this PCF CO2 equivalent to this data access view, it should basically read the corresponding value from the underlying server. Right now, it seems that there is some kind of network issue or some lagging. So let's wait for a while. Maybe Niels, can you scroll it a bit because of this control, I'm not able to access it properly. Yeah, okay. Yes, so unfortunately, we do not see a value here, but let's add it again. There seems to be some kind of network issue. Maybe we can try refreshing it.
Nur keine Hektik. You see it's live.
Not a problem. Take your time, team. It's still super exciting here for everybody, and also what I see from the questions coming in, it's super exciting. Anyway, I like to motivate here the audience to continue posting questions.
Okay, so let's continue with the demo here. As we can see, the PCF CO2 equivalent we have added, and here we see that the value is being updated, but after regular intervals and not very frequently. This is because right now, by default, the protocol being used is the REST and not the WebSocket. Now let's see when we switch to WebSocket, how the behavior changes. So let's enable the WebSocket. So the session is active here, and as we can see, or ideally we should see that the PCF CO2 equivalent value changes very frequently. Somehow today there is some network issue, but meanwhile we can have a look at the network message here. So as we can see, the AAS request is being transmitted and with the additional attributes that we talked about during the presentation. Yes, okay, here. So the values are changing here, and they are comparatively faster with respect to the REST, because in case of REST, there is the polling mechanism, but in case of WebSocket, there is this push update mechanism or the bidirectional mechanism. And as I mentioned before, we can anytime switch back from WebSocket to the REST protocol as well in the same data access view. Yeah, so right now I have disconnected the WebSocket, and ideally it should fall back to the default REST protocol here. So this is how the REST and WebSocket is being handled when it comes to the AAS, along with the translation of the request to OPC UA. So this was it from my side for the AAS. Niels, are you there?
You hear us now?
Yes, now I can hear you.
Okay, thank you very much. So that was the live demonstration, and thank you, Zoe. And I come back to the last words. Let me say so. Where's the mouse? I just want to give you an advertisement for the audience today. So as Stefan already mentioned, we have questions in the backlog, and we will talk about in the discussion in a moment. But I also want to invite you. We are all on the SBS Twice Fair in Nuremberg in November, and you will find us on the OPC Foundation booth and on the IDTA booth. So when you want to get in touch with us directly and have questions and want to have discussion about the work of the joint working group or the POC itself, you can come to us, and we will find time to talk to you and answer questions and have discussions, potentially new ideas from your side, what you think, what we can go in future, and so on. So you're invited to join us there, and I would be glad when some of you will find us there, and that we can have some talks. For the POC itself, what you saw, for sure, it's a POC, so it's not a stable product that we could show very good today. But we also have some plans how to enhance the functionality in future. And just to have two topics here is bringing that subscriptions to AAS. There's also work ongoing in the IDTA talking about that one, and we will see how this will go in future. And yeah, I'm very excited how to see how it will evolve in the future. And another topic is that we didn't present today is how we deal with write operations. So you see only read today, static reads and dynamic reads. Last but not least, I will say a thank you not only to the team you learned today, but also to the people that are in the background and helping us a lot to realize the POC, and also all of them are members of the different sub-working groups of that joint working group. That is Erik Barnstedt from Microsoft. We heard about him today. He is working on the automatic translation mapping of the AAS submodel templates to OPC UA, and he is also a member of the sub-working group generic mapping. And as you already mentioned, we are heavily working on aligning the demonstration, the POC of Erik, with the work of the generic mapping working group. Wendy Armstrong from the OPC Foundation, he is building the first software stack for the OPC UA West server and client, and he is strongly supporting us getting our stuff into that code from him. And last but not least, Georg Bieler from Siemens, he is supporting us and also the sub-working group generic mapping. This is knowledge about information models. And it's not zufällig occasionally that Georg and Constanze has the same last name. Georg is the father of Constanze. Yeah, now before we start the Q&A session, that's my next slide. I will just show my last slide and let it there for a moment because I forgot it in the presentations that we had in the past, and that is the contact page. When you want to get in touch, as I said, you can meet us on the SBS fair, and you can also contact me if you want to. My email address is here, frank.volkmann@siemens.com, and also my postal address, but I guess the postal address is not so important in today. So thank you very much to everyone, and I see Stefan already switched on his camera, so we can start the discussion round now. And Stefan, I do not see the questions, so you really have to tell the questions, and then we can see how who can answer them.
For sure, but we mentioned that we are stopping the recording because before we start the Q&A part, but before I stop recording, it's my pleasure to have here a few last words to you, Frank, leading this proof of concept here from Siemens, but also my special thanks to all your experts, to Zoe from the IDTA, but also here for Constanze, all the best, Constanze, become well again soon, and Niels. I like to specifically express that this was a joint webinar, so I take the liberty to also speak in the name of the IDTA here to send a big thank you to the team. I think it was great to bring you together. I personally enjoyed that all of you also shared your personal experience, what you learned. I was a little bit smiling that you also learned, oh, what is really the other side delivering and what is the aim. So maybe we should bring together developers much earlier together from different camps. But you showed really nice how these technologies fit together. And bringing in new talents, younger talents like Niels is always good because remember, OPC UA is now for 20 years nearly released, and having fresh younger people is always a pleasure. So welcome, Niels, for the future. With this, I'm stopping the recording. Thanks again. The slides and material will be available and shared by both organizations. With this, again, thank you.